day, everyone. I am Via Gabui, and I will be reporting Chapter 9 Transport Layering together with Mr. Oriarte Earl John. Transportation of data, role of the transport layer responsible for establishing a temporary communication session between two applications and delivering data between them. Link between the application layer and the lower layer that are responsible for the network transformation. The transport layer is responsible for establishing a temporary communication between two applications and delivering data between them. The transport layer provides services such as connection, oriented data stream support, reliability, flowchart, and multiplexing. Transportation of data, transport layer responsibilities. Tracking the conversation. Tracks individual conversation flowing between a source and a destination application. And under the tracking of conversation, we have the segmentation. Segmentation divides the data into segments that are easier to manage and transport. Header use for reassembly is used for tracking. Next, we have the identifying the application. It ensures that even when multiple applications running on a device, all applications receive that correct data via port number. So in the image below, the transport layer tracks each individual conversation flowing between a source application and a destination application separately. Transportation of data, conversation, multiplexing, segmenting the data into smaller chunks enable many different communication to be multiplexed on the same network. For example, in the image below, segmentation allow conversation multiplexing multiple application can use the network at the same time, and it is located in the upper network layers. So aside from that, segmentation facilitates data transport by the lower network layers. Moreover, the transportation of data transport layer reliability. TCP or the IP provides two transport layer protocols, namely the Transmission Control Protocol or the TCP, considered reliable, which ensures that all of the data arrives at the destination. Additional fields needed in header, which increases size and delay. Aside from that, the User Datagram Protocol or the UDP does not provide for reliability, fewer fields, and is faster than TCP. In the network access, we have the LAN connections and the WAN connections. In the internet, we have the IP. And in the transport, we have the TCP and the UDP. TCP transmission protocol is one of the main protocols of the internet that enables application programs and computing devices to exchange messages over a network. UDP or the User Datagram Protocol operates on top of the Internet Protocol or in the IP to transmit datagram over a network. So under the TCP, we have the application of the FTP or the File Transport Protocol that refers to a group of rules that governs how computer transfer files from one system to another over the internet. Aside from FTP, we have the HTTP or the Hypertext Transfer Protocol, that distributed collaborative hypermedia information system. Also, the WWW or the World Wide Web. Aside from that, SMPT is the Simple Mail Transport Protocols. And we also have DNS or the Domain Name System that is used to identify computers reachable through the internet. That is under TCP. And in UDP, we also have the DNS present and also the TFTP. So TFTP is the Trivial File Transport Protocol, is a simple protocol that provides basic file transfer function with no user's authentication. Transportation of data, TCP transport is similar to sending track packages. If a shipping order is broken up into several packages, a customer can check online to see the order of the delivery. A file is sent to a server using the File Transfer Protocol or the FTP application. TCP tracks the conversation and segments the data to be sent into six segments. We have the ISP1, the Internet, ISP2, the FTP, and the server farm. Transportation of the data, TCP. TCP have three responsibilities, namely numbering and tracking data segments, followed by acknowledging received data, and lastly, retransmitting any unacknowledged data after a certain period of time. The transport layer is also responsible for managing reliability. Some applications may not require reliability. Transport layer requirements in from application to application. TCP and IP suite provides the two transport layer protocols transmission protocol of the TCP and the user datagram protocol or the UDP. IP uses these transport protocols to enable hosts to communicate and transfer data. TCP is considered a reliable full-featured transport layer protocol which allow for packet data delivery confirmation. Aside from that, in contrast, UDP is a very simple transport layer protocol that does not provide any reliability. The use of UDP. First, for less overhead, and second, to reduce possible delay. Third, best effort delivery or the unreliable. Fourth is no acknowledgement. Fifth, similar to a non-registered letter. So, UDP is reliability is not required in UDP is a better transport protocol. UDP provides the basic function for delivery data segments between the appropriate application with very little overhead and data checking. Some applications do not require reliability. Reliability incurs additional overhead and possible delays in transmission. Adding overhead to ensure reliability for some application should reduce the usefulness of the application and can even be detrimental. Transportation of data, the right transport layer protocol for the right application. TCP databases, web browsers, and emails clients that all require the data that is sent arrives at the destination in its original condition. However, in UDP, if one or two segments of a live video stream fail to arrive, if disruption in the stream may not be noticeable to the user. So, the required protocol properties in UDP is fast, low overhead, does not require acknowledgement, does not resend lost data, and lastly, delivers data as it arrives. While in TCP, required protocol properties are reliable, acknowledges data, resends lost data, and lastly, delivers data in sequence order. TCP and UDP overview. TCP features. First, it establishing a session. Next is the connection-oriented protocol to be followed by the ensure the application is ready to receive the data. Next is negotiate the amount of traffic that can be forwarded at the given time. Next is reliable delivery, ensuring that each segment that the source sends arrive at the destination. Same order, same delivery. Numbering and sequencing the segments guarantees reassembly into the proper order, followed by flow control, and lastly, regulate the amount of data source transmits. Aside from that, TCP layer protocols is better choice for application whose segments must arrive in a very specific time sequence to be processed successfully. Application in which all data must be fully received before any is considered useful. Application requirements in TCP includes databases, web browsers, email clients, and applications. TCP header. Source and destination port used to identify its application, sequence number used for data reassembly, acknowledgement number indicates data has been received and ready for the next source, and TCP is a stateful protocol. It keeps track of the state of the communication session by recording which information it has sent and which information has been acknowledged. Each TCP segment has 20 bytes and overhead in the header encapsulating the application layer data as shown in this image. UDP features. UDP features have data is constructed in order that it is received. Next is any segments lost are not resent, followed by no session establishment, and lastly does not inform the sender about the source reliability, just like how this image portrays. Let's proceed to TCP and UDP overview of multiple separate communications. Users expect to stimulously receive and send email, view websites, and make a call. VoIP phone call. TCP and UDP manage multiple conversation by using unique identifiers called port numbers. Multiple separate conversation. The transport layer must separate and manage multiple communication with different transport requirements. Different applications are sending and receiving data over the network stimulously. Unique header value allow TCP and UDP to manage this multiple and stimulus conversation by identifying this application. What is port numbers? So, source port, originating application port that is dynamically generated by sending devices. Example is shown in the image. Each separate HTTP conversation is tracked based on the source ports. Destination port tell the destination what service is being requested. Example is port 80 web services are being requested. Source port. The source port number is dynamically chosen by the sending device to identify a conversation between two devices. An HTTP client usually sends multiple HTTP requests to a web server at the same time. Each separate HTTP conversation is tracked based on the source port. So the destination port used to identify an application or services running in the server. And server can offer more than one servers at the same time, offering a web services on port 80 and FTP on port 21 stimulously. That's all, thank you. And now let's proceed to chapter 9.2 to be presented by Mr. Earl Oriarte. Thank you.
Good day, everyone. I am Earl John Oyarte, and I will report the continuation of Miss Gabuli's report, The Transport of Layers. So, let's start. TCP socket pairs. A socket pair is made up of two unnamed sockets that are connected. It looks like it looks a lot like a pipe and used the same way. So furthermore, socket pairs are created with the socket pairs function declared in sync or sockets. Port number group. The port numbers are divided into three ranges. Well-known ports. The well-known ports are those from 0 to 1023. Registered ports. The registered ports are those from 1024 to 49,151, dynamic or private ports. The dynamic or private ports are those from 49,152 to 65,553. Okay. Nested command. What is a nested command used for? A nested command generates displays that shows network status and protocol statistics. You can display the status of TCP and UDP endpoint in the table format. Rotating table information and interface information. TCP server process. An open command is sent to a TCP device. The server process issues a use command, then a read command while waiting for a client process to respond. Before a client may create a connection, the server must be listening. Furthermore, before the data communication can commence, the client and the server must exchange synchronization and acknowledgement packets. TCP connection establishment. Before a client may connect to a server, the server must first bind and listen for the connection on a port, which is known as a passive open. A client can initiate an active open after a passive open has been established. TCP three-way handshake analysis. To create a secure connection, TCP uses a three-way handshake. Both sides synchronize SYN and acknowledgement each other over the full duplex connection. Synchronize acknowledgement and acknowledgement are the three steps in the exchange of these four flags. Furthermore, three-way handshake or TCP three-way handshake is a process which is used as in a TCP IP network to make a connection between the server and the client. In the three-step process that requires both and the server to exchange synchronization and acknowledgement packets before the real data communication process starts. Okay. TCP reliability ordered delivery. TCP is a dependable stream delivery protocol that ensures that all the bytes received are identical to those transmitted in the same order. Moreover, since packet transfer by many networks is reliable, TCP receives this using a technique known as positive acknowledgement with retransmission. TCP reliability sequence number and acknowledgement. The sequence number is the first byte of data in the TCP packets that was sent, also called as TCP segments. The sequence number of the next byte the receiver expects to receive in the acknowledgement number. TCP flow control. Window size acknowledgements. The receiver window size is a competent of the TCP frame. The maximum size of the window is 65,535 bytes because the length of the window is 16 bytes. The size of the window is determined by the receiver. With each acknowledgement, the receiver communicates and currently available receiver window size. TCP flow control. Cognition avoidance. TCP employs a multi-phase cognition control approach to avoid cognition collapse. TCP keeps a CWN for each connection, limiting to a total number of unacknowledgement packets in transmit to end. This is similar to the sliding window used to the flow control in TCP. UDP datagram assembly simply resembles the data and send it to the program in the order it was received. If the data sequence is critical to the program, it must establish the correct sequence and how the data should be processed. Okay. UDP server processes. The UDP server process choose a port number from a list of possible ports numbers and uses it as a conversation source port. The destination port is normally the server process well known or registered port number. Application use that uses UDP. Numerous key internet applications use UDP including the Domain Name System or DNS, the Simple Network Management Protocol or SNMP, the Rotating Information Protocol RIP, and lastly the Dynamic Host Configuration Protocol or DHCP. Voice and video traffic is generally transmitted using UDP. So that is our report, guys. So thank you for listening and have a great day.